I'm going to try to shine a historical light on our language and tell you a story about the electric vocabulary. It all begins over 2,600 years ago. An ancient Greek called Thales of Miletus is thought to be the first person to observe what we would today call electrical phenomena. He discovered that a piece of amber, when rubbed with fur, could pick up small pieces of straw. In Thales' language, amber was called electron. For a long time, that was pretty much all anybody knew about the subject, and nature had to wait around 2,200 years before any new investigations were made into amber's properties. William Gilbert, a 17th century English scientist, discovered that with a careful experimentation, a number of other materials could display the attractive properties of amber. He also found that they could attract objects besides straw. Gilbert named these amber-like objects after the Greek for amber. He called them electrics. About 40 years later, in nearby Norwich, Sir Thomas Browne carried out similar experiments. He didn't figure out anything different from William Gilbert, yet the way he described the experiment coined a word we use all the time. The way he saw it, when you rub, say, a crystal with a cloth, it becomes an electric object. And just as we speak of elastic objects and say they possess the property of elasticity, electric objects possess the property of electricity. The 18th century French physicist Charles Dufay was the next person to make an important new discovery. He found that almost any object, except for metals and fluids, could be turned electric after subjecting them to a combination of heating and rubbing. In addition, he found that when two electrics are placed near each other, they sometimes attract and sometimes repel. With this extra knowledge, Dufay found that there were two distinct groups of electrics. Any two objects from the same group will always repel, while a pair of one from each group will always attract. Despite these new discoveries, Dufay's descriptions of the physics are all lost to history. Instead, it is the vocabulary of a charismatic young American that we still remember and use to this day. Benjamin Franklin heard of the work going on in Europe and started his own playful experiments. He quickly learnt how to make electric devices that would de-electrify by producing very large sparks. Keen on mischievous pranks, Franklin would often shock his friends with these machines. As he built more effective devices, he likened the act of electrifying and de-electrifying to charging and discharging weaponry. It didn't take long for Franklin and others to realize that it was possible to link these weapons of mischief together. Franklin, continuing with the metaphor, likened this grouping to cannons on a ship. The gun deck on a military vessel fired their cannons simultaneously in a battery. Similarly, this electric battery would discharge all at the same time, causing large sparks. This new technology raised an interesting question. Was a lightning cloud just a large electrical battery? Franklin's description of all this was as follows. He supposed that there is a substance he called the electrical fluid that is common to all things. If, say, a person rubs a glass tube, this rubbing or charging causes a flow of this fluid, or an electrical current, to move from the person to the glass. Both the person and the tube become electrics as a result. Normally, if the person was standing on the ground, their electrical fluid would return to normal, with an exchange from the common stock of the earth, as Franklin called it. Standing on something like a wax block can cut off this supply. Franklin said that an object with an excess of this fluid was positively charged, and something lacking this fluid was negatively charged. When objects touch, or are near each other, the electrical fluid can flow between them until they reach a balance. The bigger the difference in the fluid between the two objects, the larger the distance the fluid can jump, causing sparks in the air. And it is the material of the object that determines if it gains or loses electrical fluid during charging. These are Dufay's two groups of electrics. You might have heard the phrase, opposite charges attract, like charges repel. That's why. For the next 150 years, Franklin's theory was used to develop many more ideas and discoveries, all using the vocabulary he invented. This scientific inquiry brought forth technological advances, and eventually scientists were able to take a closer look at the electric fluid itself. In 1897, J.J. Thomson, working in Cambridge, England, discovered that the electrical fluid is actually made up of small particles, named by the physicist George Stoney as electrons. And so we return to the ancient Greek word for amber, where our story began. However, there's an epilogue to this tale. It was discovered that these electrons flow in the opposite direction to what Franklin supposed. Therefore, objects that are positively charged don't have an excess of electrical fluid. They actually lack electrons. Yet, instead of relabeling everything the other way around, people have decided to hold on to Franklin's vocabulary as a matter of habit and convention. While acknowledging the discovery of electrons, they kept Franklin's flow of electrical fluid, renaming it conventional current. The electron has become the salmon of electricity, swimming upstream in a ghostly river of conventional current. This can be understandably confusing for many people who aren't familiar with the history of these ideas. And so, I hope, with this short story about the electric vocabulary, you will be able to see through the accident and whimsy of this subject, and can gain a clearer understanding of the physics of electrical phenomena.